In this lesson, we'll begin by clicking on Geometry and then select millimeter as the working unit of measurement. We will import a CAD file, so we'll select the File menu option, Import External Geometry File, and then select the file tutorial111.igs. In order to complete the import process, we'll now click on the Generate option. We'll next measure the thickness of the bracket by first zooming in and then clicking on the Edge Selection tool. Then we'll select the edge and observe the 3 mm length in the status bar. The next step is to create a thin surface representation of the bracket. We'll start this process by first clicking on the Face Selection option, which allows us to select the 3 faces of the bracket shown here. Now we'll click on the Thin Surface option in the toolbar. In the Details window, we'll now enter a value of 0 for FD1 thickness and then press the Enter key. For the FD2 face offset, we'll enter a value of 1.5, which is half the thickness of the material, and then press the Enter key. We'll now click next to Geometry and then Apply, followed by clicking on the Generate button. We now have a surface body which is offset by 1.5 mm from the selected faces. Since our surface body is now complete, we'll move to the Simulation module after saving our project. Now that we have entered the Simulation module, we'll check that the working units are set to millimeters. Notice that there are question marks next to Geometry and Surface Body in the Outline View window. This is because our part's thickness is defined to be 0. We'll correct this now by entering a thickness value of 3 in the Details window and then press the Enter key. Next, we'll rename the part by right-clicking on Surface Body in the Outline window and then select Rename, followed by entering Thin Bracket. Since our bracket is made from ASTM A242 steel, we'll import this material's properties by first selecting Thin Bracket in the Outline window, and then in the Details window click on Structural Steel, followed by selecting the option Import. Now in the dialog box, we'll select Tutorial Material Database, and then click on the radio button next to ASTM A242, followed by clicking on OK. We'll now set the analysis type by clicking on New Analysis and Static Structural. The next step is to impose the boundary conditions, so we'll select Static Structural in the Outline window, and then select the 3 edges, followed by selecting the options Supports and Fixed Support. To apply the loads, we'll first select the 2 arc segments that describe the hole, and then click on Loads and Force. In the Details window, we'll change the Define By options to Components, and then key in 150 for the Y component, and then press the Enter key. To define the type of results we wish to calculate, we'll click on Solution in the Outline window and then click on Deformation and Total. The mesh will be controlled by specifying the element size. This is done by first clicking on Mesh and then selecting the edge shown here. Now we'll click the right mouse button and select Insert, followed by Sizing. In the Details window, we'll now enter a value of 5 for the element size and leave the edge behavior parameter set to Soft. In order to view the mesh, we'll now right-click on Mesh and select Generate Mesh. We are now ready to solve the model, so we'll click on the Solve button. To examine the results, we'll click on Total Deformation and observe that the front edge of the bracket has moved approximately 1.5 millimeters as a result of the 150 Newton force.